Hello everyone, I am Sachin and I will be presenting our project on porting large language models to mobile phones. Our goal is to create a fully functional offline AI assistant that runs entirely on an Android emulator with no internet connection. Our project involves three main components: a Kotlin-based frontend for user input, a local LLM running on Termux, and a Python backend that schedules calendar events. When the user types something like schedule a meeting at 4 p.m. on June 25, it is saved to a file. The shell script detects this, sends it to the LLM, and the backend parses the response and opens the Android calendar with the details pre-filled. Here in this slide, we can see a demo of our offline question answering capability. The app lets user enter queries, which are answered locally by the LLM. Here no cloud service or internet is required to answer the query. Here's how the scheduling works. After launching the Atomic server, the user selects calendar task in the app, enters a natural language prompt like schedule a meeting on June 25, and now the LLM parses the event details. The system confirms the task and opens the calendar app to schedule it. These are the key backend components that handle prompt monitoring, language model interaction, and calendar event creation in our system. Firstly, prompt file watcher. This script keeps checking a file for a new text prompt. When it detects a change, it automatically runs the Python script to process the prompt. This way, the workflow runs continuously without manual steps. Prompt processing and LLM request. The Python script reads the prompt from the file, sends it to the local language model API, and gets a response. It then extracts important details like date, time, title, and location from the response. Event extraction and calendar launch. The extracted details are converted into calendar event file like ICS. Then the script triggers the Android calendar app with these event details, so the user can easily add the event to their calendars. Here are the key skills and insights we gained while working on this project. Firstly, we learned how to connect all parts of the system. Our Kotlin based app, the local LLM running in Termux, and the Android's calendar into one smooth working pipeline. Secondly, we gained a solid understanding on how to send prompts to the LLM, parse its response, and extract the right information to trigger real world actions. Thirdly, we explored automation through shell scripting using file watchers to trigger backend logic without manual steps. And finally, building a Kotlin app gave us practical experience with Android UI development, handling permissions, and managing user inputs efficiently. Changes made from the initial architecture diagram. We made several architectural improvements. We replaced Flask with file-based communication for simplicity. We also switched to Android's native calendar using AM start intents and added a shell script to automate prompt detection and processing. Model selection. We choose Orca Mini 3B due to its small size, just under 4 GB RAM with 1 to 2 seconds inference time, and its compatibility with llama.cpp. We evaluated other models like Mistral and GPT-J but found them too heavy for local mobile use. And the other one was Tiny Llama, which was lighter but less accurate. Project goals achieved. We set out to build a completely offline AI assistant for mobile, and we achieved that using Orca Mini and llama.cpp for efficient local inference and the Android emulator. We successfully implemented a user-friendly Kotlin app that accepts natural language input. The input is saved and detected by our backend, enabling seamless interaction. The LLM accurately extracts key details like title, date, and time from user inputs, even when parsed in different ways. Our Python backend processes this data and uses Android intents to open the calendar app with all event details pre-filled, requiring no manual entry. And most importantly, the entire system runs locally without any internet connection, ensuring both privacy and accessibility. That makes our solution lightweight, secure, and ideal for offline environments. Challenges and hurdles faced. We faced several key challenges during development. First, the emulator storage was limited, causing slowdowns and crashes. We had to clean up frequently and optimize how data and models were stored. Secondly, integrating LLM outputs with Android calendar intents required precise formatting and handling permissions correctly. Thirdly, parsing unstructured responses from the LLM was tough. We used regex and fallback checks to extract reliable event details. Finally, debugging communication between the Kotlin app, shell script, and Python backend took time. We added logging at retry logic to make the system stable. Each challenge made the system more efficient and resilient. Thank you for your time and attention. We hope you found the project insightful.